Well, good afternoon everyone, and it's a great pleasure to be here sharing about my expertise. I'm the chairman of the United Nations Association Climate and Oceans for the United Kingdom, and we are part of the United Nations Decade of Ocean Science for Sustainable Development. And part of my background is I've led teams in Latin America and the Caribbean, and currently here in the United Kingdom and beyond, an international team as part of UNESCO associated with all that scheme there. So we'll try to share the key interactions between the Earth's atmosphere on the one hand and the oceans. It was great that Ian showed us already this picture of the Earth from space, because this is when the Apollo 13, the astronauts there, looked back to the Earth. One of the first things they said, they looked back to the Earth, it's a blue planet. That was the first sight that human beings have ever had from the Earth, from space. And they realized that it's a blue planet. We have to remember that 3 parts of the world is actually water. So how does the ocean, this is the next point, I'm going to explain a bit more about this. The ocean sequestrates the natural CO2 from the atmosphere. There's 2 ways that the ocean does this. Let's remember the ocean is always in motion, always currents. You go down the sea, I'm glad that we're here in a coastal sea, because you can go down there and you will see the waves. And every wave comes in with energy, and that energy is transporting heat, it's also transporting CO2. CO2 is dissolves very rapidly in contact with the atmosphere, in contact with the salty waters in the ocean. And this is the first warning. CO2 dissolves much faster, or more efficiently, shall I say, in cooler waters. And that's one of the problems. With a warmer planet, we also have an impact in a warmer ocean, and becomes less efficient in that dissolution. And that, through the natural water movements of the dissolved molecule of CO2, starts sort of dragging and into the deep ocean. So the deep ocean is our biggest ally, our largest ally in terms of dissolving CO2. And if we count how deep the ocean is, we count the whole ocean, the ocean is 1,000 times more, has more thermal capacity than the atmosphere. 1,000 times more. This is probably the most important part of the service that the ocean does for us as a whole planet. The ocean is the Earth thermostat. It's the global ocean circulation or conveyor belt. And it's the way that the planet has to redistribute excess heat from the surface of the planet into the cooler waters down the deep and back. It's like a radiator, the old radiators in the cars, if you remember. It's a cooling system, all right? So that's why we tend to look at this as one ocean. We know the Pacific Ocean and the Atlantic Ocean and Indian Ocean and so on. But really, the ocean is connected. Just to give you an example, when you think about that image, for example, we in the British Isles and Europe, we are roughly at the same latitude as Canada, aren't we? Yes, in the Northern Hemisphere. And yet our winters are much, much milder than those in Canada. Canada, you know, the same latitudes, there are how many meters of snow usually, but meters, you know, of snow. Here in the south coast, we hardly ever get snow, here in Eastbourne, for example. Now the reason is because of the ocean. The ocean captures all the excess heat, the heat from the Bahamas, Cuba, the West Indies. I wish we were there, in the winter, in our winters here. And it transports through the Gulf Stream the heat from the Caribbean, and when it encounters the cooler waters, that's the key thing, the difference. the cooler waters of the North Sea, the Arctic Sea, the warmer waters is pushed down by the colder waters and releases the heat into the atmosphere. But the ocean has a biological pump, and that again is being damaged. This is absolutely essential. And the biological pump for sequestration comes from organisms, living organisms in our sea waters. Just to give you a visual, I've got a little friend here. Oh, how I love scallops. Do you like scallops? I do. Right. When we look at this lovely fellow here, which I enjoy teething, so I'm very sorry. What we have here is CO2 captured by the creature that was inside here, and he was feeding from phytoplankton, and he created his shell from that CO2 dissolved in our coastal waters. And this is very important actually for us in Sussex, because there's in coastal waters, for example, we have underwater forests, and the UK particularly, we have underwater forests which do exactly the same as forests on land, which are doing all this process of photosynthesis, but underwater, and they're called the kelp forests. In the total oxygen budget of the Earth, 50%, think about this, 50% of the oxygen that we breathe on this planet comes from underwater, comes from the ocean, because of plankton particularly, for all these algae, particularly here the kelp. Kelp is very abundant across the United Kingdom. Most coastal shores have them, different species. About 60% of the coastal around the UK it's covered, the coastal areas of kelp forests. Kelp forests are more efficient in cooler waters. Cooler waters are more efficient, and they can reproduce easily. They reproduce with spores, you know, and they're not as such a carbon sink, because the lifespan of a kelp, it's a plant, the seaweed as such, is between 1 year to 18 years, 20 years maximum. Okay, but the rate of growth is faster than any tree on land. It grows from 50 centimeters to 1 meter per day. Kelp forests are also very, very important for marine life and biodiversity. That's the other interesting, very important thing to think about. Why is that? Because they produce, like any forest on land, that Ian will tell us in a minute, they are hiding places for fish, lobsters, seals, dolphins. So the ocean plays a vital role in regulating and controlling the natural planetary balances, and it regulates the climate fluctuations. And that is the problem, because we're damaging the oceans, not only because of pollution, but also because of global warming. It becomes less efficient to capture those two pumps, the physical pump, the biological pump, and then we have a big, big problem.
Well, thank you so much, Gonzalo. That was brilliant. There's so much going on right on our doorstep.